Hey guys, in this video, I'll be trying to write a job queue in Golang. So a job queue in the sense, so it's not a distributed job queue. It's just a single node job queue where you can give, I guess, different types of jobs. It's not a single purpose job queue, but we can give different types of jobs and expect some work to be done in the background. So that's so I think the main problems with this is persistence and to take care of failures as well. And we might need some retry mechanism. I haven't looked much into it, but I know what a job queue is. So there are the bigger alternatives are like there is RabbitMQ and Kafka. They're very much like highly sophisticated where they are distributed. They run on multiple nodes and they have this worker and slave pattern, no master slave pattern where nodes communicate with each other. So we are not going to do that. This is going to be a single node. You can it's just going to be a Go binary, and you can just run this on a single node, and each node is separate from one another. Node in the sense you can take that as a mission. Mm, I think yeah. I'm just trying to let's do. Where is okay? It was doing necessary. So I just want to show um what components we are going to have, at least what I think for now, because I do not know what exactly is needed, since this is not prepared. I don't have a prepared script which works. We're just going to write on the go. So first thing is that we are going to create a Go application which um so we have two paths. One is the API path and another is we don't need an API. We just need to have some um we just need to have the job queue which any other application can call. But anyhow, they're going to be communicating via HTTP. So I guess we'll need to have some server. But before that, yeah. So the components which I was thinking is we need a dispatcher. So this is not what do you say, the entire application. This is just the queue part which I was thinking. So there's a dispatcher and so there's this worker, actual workers if there are multiple, and there'll be some kind of result acknowledgement or retry mechanism. I think we need to just put it here. Dispatcher dispatches the jobs to the next available worker, and this picks up the job, does the job, and then this. I think it should be putting. We need a. Let's do a DB here. Let's say we have a DB. I'm not sure, but if we have a DB here, the worker will be communicating with that as well, right? So this is inside the queue, I guess. Maybe this runs inside an HTTP server, right? Maybe above this just a wrapper is HTTP server. So this is maybe, I don't know, running in some API. So we can have a couple of APIs. One is to, let's say, schedules a job, right? Let's say current jobs, maybe it's running jobs. Running in the sense, I think we can just get your jobs, right? So yeah, this is what we want to do. For HTTP server, I just want to keep it very minimal. But before that, I think I'll just go to the SASE folder. I think it's, yeah, so we need to create one. What should we name this? Let's say GoQ. We need to do the mod. in it just to poke you. So for now I'll just zoom this in. So as usual, we'll just have a main function which says hi. And we can just say main.go. It should say hi. Um, so the first we need a HTTP server. I'll just go for Go Fiber. So this is very much simple as far as I know. I'll just pick this up. Let's install and get this running. Oh, lots of dependencies. Okay. So let's try to do Go run here. Not sure if it's running. I think it's, yeah. So I guess if we go for localhost 3000, it should say, yeah, it says hello. So what we actually need is, let's actually create a make file. So this is a run, which is go run main.go. And just say make run. So the first thing is I don't want hello world. So probably, can I do this? For example, I have this. I've not worked with fiber that much. So can I do this here? Actually, if I can do that. Yeah, I think I can do that. Okay, so the first thing is we need to schedule one job. That's API. And the other is get two jobs. So before that, I think this should be the final part where we attach the job thing. But before that, we need the queue to be ready. So that's the main part. So I'll just create, let's say SRC, and inside SRC, I'll just say dispatch. Not sure if this is the right way to do it. Right, and I have this worker, which will have worker.co. So both of this is package main. Will this run? Yeah. So as I said, for the dispatcher, right? We for the dispatcher we need to give an input to itself. So let's say there's a dispatcher. Okay, let's actually go about. There is this dispatcher, but before this we need to give an input for this. I don't know, like let's say, so we need to give this so that this can pass this job to uh, the worker. But before that we need to make sure, we need to decide on if you're going to pass the JSON string as it is, or is the dispatcher going to actually do something and just take minimal info from the user or from the client, and then just do what's needed to give that payload to the worker. So for now, the payload might look like this. So let's say task is going to be, let's say task one, sleep, friend. And what else do we need? Let's say there's some ID because we need to identify the job. Right. So this is going to be id something id 124. So this should be the minimal info, but we might add more to this. So let's say this is a JSON you're going to give to the dispatcher. Actually, let's remove the ID from here. To the dispatcher, I'm just going to give this task which is needed, and the dispatcher is going to give this to the worker. So the dispatcher is giving to the worker, which is a JSON added with this ID file. I think it should just be here. Copy this and do this. Right. How do I break this? I think this is fine. So we'll do something like this. We might need to add some other variables like number of retries already done, or is it not done? We don't know. Like, is it done or not done? Maybe status. I think that should be good. Status. I think we can have three types of status, which is not starter, or let's say waiting, in progress, in queue. Sorry, waiting. I think processing, and then fail or success. Or let's say okay, not okay, right? So this is the status, right? And then maybe we can have some metadata as well. I mean, I don't know, but we could have. So the another thing is we have mentioned as workers. So it's not required that there is just one worker. There can be multiple workers, but we're going to be starting to build with one worker, and then maybe we can see how to build a worker pool and then pick something out of it. And when it's done, we'll just put the worker back into the pool. So right now it's everything in memory. We're not going to do persistence for now. Let's see if things go well. I think then we can see. For the dispatcher, I think let's start with the struct dispatcher, right? And a new dispatcher as well. So this is the boilerplate. So what do we actually need to do? So should we start with the worker? Well, I'm not sure which way to go. Again, here we can just say this is one worker, right? We can have a new worker. So we have the dispatcher and worker structs. So now what do we actually need for this worker? So here we need the task name, the ID, the status, and metadata. For now, let's just go with task and ID, I guess. So I will just go task is a string and ID is also a string. And you're going to give that here, task and ID, which is a string. It will just return that. So now what are we going to do with this? So for a given worker, we need to have let's say a work. So the job of the worker is to do a work, right? Let's say do work. So we need to make it do some work. And how do we know what work it's going to do? So this is I'm just thinking. So there are multiple parts moving, right? So one thing is that um, how is this even a queue? Because everything is sync. Where is async part? So that will be the portion after which we complete the worker, because we need this part where the async. What do we need to do with the async part, right? So we just need to work on the worker now. So let's say the job of the worker is to take take a task and then do it, right? So what it needs is it needs a task. So for that, I think it needs to have some list of tasks which it can do, right? So let's say we need also need a task um, list, I guess, which will be a map of string and say, func. How do we do func in? Can we do this? Okay. So what this means is that for every task, right? So here, for example, we were saying the task is sleep time, right? So that needs to be mapped to some work here. So the worker needs to know what to do when we get sleep 10 as a task, right? Um, so let's actually define that. So task list is going to be make map of string of func error. So we need a map, and for the task list, I'm going to send T. Let's rename this as T. So right now it's empty, but we need to statically populate it. Let's say I have this sleep 10, right? I don't know. It sleeps for 10 seconds. I'm not sure. And for each second, it's going to print. So I have this sleep 10. So for a range of 10, I'll just do. Is it hours.sleep or what do you sleep? Time.sleep, right? Yeah. So I think I'll just do 1 into time.second and just print slept for 1 second. Let's just print that. Yeah, I'll just do that. Actually, this needs to return error because the map of string is going to return error. We'll just return nil for now because we don't have any errors going to be happening here. And I'll just map it like this. Sleep 10 is going to be sleep time. Right. So when you're going to do a work, right? We'll go in. We need to search for the task there. So I can just say task and okay. We can just search the task list for the task. And if not okay, I can just return. And if it's okay, I'll just call the task, I guess. Right. So this is what the job of the worker is to do. Maybe we'll return an error here. Return errors.new. I'll just print here. Task this not found. Just a return task because that returns an error, right? Okay, we can just do error f. So yeah, we do the work here. Yeah. So the task and ID which we are getting here, we are not going to be modifying it, but we need an ID here. So should the worker create the ID, or I think the worker should create the ID, right? We don't need ID here. Let's create 10 character random go. Just go here. Let's do this. just do utils ran.go. I can just call um, the id as rand string reons, right? But why am I not able to call this? So why I'm not able to find this? There's also a package main, right? Anyone call the dispatcher? No. Okay, I think the package structure is not the same. Maybe I'll do one thing. Just move everything outwards. And now here, yeah, we should be able to call. Let's save. Go to the worker, and for the ID, I'll just call rank string runes of just a 15 here. So I don't need the ID. I just need the task. So this so the do work actually needs to return a struct, right? Or I think so the worker and the task is different. So what I'm thinking is let's separate the task. So the worker creates a task and then it maybe returns the task ID to the dispatcher or whoever called it. But I think that's fine. I think that is fine. What I'm thinking is should we separate this into a task module and like we could just delegate this there because the job of worker is not to a worker can have multiple tasks. So his job is to spawn the tasks, I think, but the dispatcher is doing the same thing. It's calling the workers. Well, let's do one thing. Let's keep the worker not tied to a task. Let's remove this here, and when do work comes in, I'll just put that here, right? Because we don't need it here. Mm, because it shouldn't be tied to a task. So what happened? Cannot use w.task list map of. Wait, w.task was also a string, right? Cannot do this. This is also a string. Okay. What is returning? Why is this returning error? Why is this throwing map index expression of func error as string value? It's weird, right? The task list has If I keep this as w.task, it doesn't work. Then where is okay the do work? What's the problem with do work here? Okay, I think it's thinking it's in the task list. If I put a string here, I don't know what's this works, but this doesn't work. Why is that? Cannot use on task list. Map and the expression of string value and assignment. Okay. Okay. I think this is the problem. That's what I think. It's very weird. Like, so now the worker is not tied to anything, any task, right? So we can create a number of workers, but when we make them to do work, we can just give a task to them. So now it's very loosely coupled to the task. I think this is fine. We should do the work. Let's create sleep 5 as well. So this will sleep for 5 seconds. Right. And just um yeah, this should, I think we need to add this here. When a task named sleep5 comes, we need to call sleep5, the task itself. So this is a function we are calling it here. So this sleep10 or sleep5 is what we are calling it in T here. So now the thing is, after doing the work, what do we need to do? Right? We don't know if it failed or if it passed. So I think what's the role of a dispatcher? It's just, should we? I think which one is the OSQs? Yeah, I think dispatcher actually has more control than I thought. So we need to not only call the workers but also update the tasks of them. So when we return this, right, we can we just so the ID will be tied to this anyhow, the worker itself. So when the dispatcher's job is to call this do work, um, see for any error. If there's some error, we'll update the status and do the retry thing, or else we are just going to say it as it's done. Right? So for before that, what do we need for the dispatcher? So it needs to dispatch something. Um, so so it's need to do some. It needs to do something. But what is it? So anyhow, I know we need a worker. For now, let's go with one worker. I'll say one worker, right? And the worker is going to be so right now we're just going with an empty worker here, and when dispatch call comes, we also have call a worker. So we can, for now we can just do d.worker dot just do the work for this task, right? And so the dispatcher needs to maintain a list of tasks. So the task, I think it should be a struct which has an ID, which has a name, let's say, and the status. So when we do the work here, so the worker, so the worker ID is different than the task ID, right? So when we create a worker, this ID is attached to the worker and not the task. So the task ID, should it be handled here or in the worker, the dispatcher or the worker? So this one. So when we create a task, right, when we dispatch something, we create a task and then um, should we, instead of sending the um, task as a name, should we send the, I think name is enough. I think. This will add a task. The task is something that it has a name of the task, the work to do. So it just has the information of what to do, right? So for now, I think this is good. Um, I'm just thinking there's something missing part. That's what I'm thinking. So we have one worker for now, and whenever a new dispatcher is called, or let's say when the flow is that we call a new dispatcher and then we call dispatch this. But I'm sure like we need to have one layer above the dispatcher for abstraction, because this would be very kind of too low level to handle, not for us but for the users. If someone is trying to use this, they don't want to call it dispatcher, they just want to say queue dot rtq or do not remove from the queue or something. So yeah, so the call worker does the work, and for this we need some information, if it's done or not. If error is not equals to nil, then we need to update task status to failed and retry, or update task status to done. Okay. So it's okay, not okay. Um, but what I was thinking is, we don't really have a queue here, don't we? Do we? Because there is, as we were discussing, we anyhow need to create a queue, but if I need to put it into the queue, right? I think we need to have a queue that dispatches this task to some worker. Okay. So for now, we'll just take singular. A dispatcher has one worker and one task to do. The task has this and this, and so new dispatcher task is going to be a new task. Um, so the dispatcher is going to have some task to do, and the ID of the task is going to be this task, and the status is, what did we say for the status? It's waiting. So first, every task starts with waiting, and then when the worker is called, um, we say d dot task dot status is in the worker, so it's processing, right? So for do work, we are going to wait, but this entire dispatcher thing, it's going to be async, which is via Go channels. So this blockage of this line blocks, right? The do work blocks. So if we are going to call sleep 10, this do work is going to wait for 10 seconds. So this shouldn't block the entire queue. So that's the entire reason of using the queue system, right? So we are going to this is going to be async anyhow, so that's fine. We'll take care of that in some time. But for now, I'm just thinking like if we are calling a worker, right? Then we don't need the task here. I can just say d dot task dot id, and let's say d dot task dot status is not okay here, and here it's okay. Um, yeah, sure. Should we store the previous, maybe d dot call worker return null, for example here? Let's say this call worker returns an error. We return the error. Here we return nil. And we're going to retry this if this fails. So if so we're going to retry n times, let's say 3 times. Actually, let's do this. Retries is 0. And so for, and I don't know if I can do this, but call worker with, or can just call worker. Can I do this? No, right? Is there a while? No. Okay, for retries less than 3, or and um let's call this d dot do work, dispatch dot do work, and error is not equals to nil. We're going to do this again and again. I just need call worker, right? Yeah. But let's say for each retry, we need to wait for um, time dot sleep. Let's say I'm going to sleep for uh, how do I do time dot sleep? I'm going to sleep for, let's say, the retry count, retries into time dot minute, let's say. I think this must be time dot minute of, I think, okay. Okay, time dots. Okay, we are in time dot sleep. I just forgot it. Time dot minute into retries. So for the second retry, we're going to wait 2 minutes. For third retry, we're going to wait 3 minutes, and so we'll start with 1. Actually, we'll go until 3. So we're going to retry here, and then we'll return the error. If it still returns error. So this looks good, but I haven't tested this until now, even once. Hmm. We need to do something to test this, but okay, let's go with we need an abstraction over this, which is the queue, right? So this is the actual queue which the client or we are going to be calling. um let's say this queue is going to have a list of tasks, right? And so So the thing with dispatcher, I think I can say dispatcher. So the queue is going to have a dispatcher which will take care of them. And we are going to have a list of tasks. Let's just have that. So whatever tasks comes in, we just add that to this queue, or whatever we have right now, we just add it to the queue. But we don't need to track the status or something because that dispatcher takes care of that. So maybe, so let's hold on to this for now. For now, we just have a dispatcher. So we are going to return a queue for that dispatcher. Is going to be new dispatcher. Wait, is it tied to a task? Hmm. I think this should be inside this. And the task, I'm not sure, but status is waiting. ID we will give when we dispatch it. So I'll say d dot task dot ID is task. I can just say this. So now there are some functions which we need to do, which we need to fulfill, right? So we need to add to queue. That's actually the main purpose of this queue at least. So before that, we actually need to do so much work on the channel side because we need to make sure what are we going to. Uh, so in order to make this thread safe or async, we need to call this dispatcher in a different channel because channels are great in Go. Uh, so basically, we can each channel, right? Channel, if you're familiar with channels, then I think you know what I'm talking about. So they have this uh, channel size, so which we can use it as an actual queue. So that's what I'm thinking. So what the channel is going to hold, maybe the task ID, right? So let's just do go build on this once. Function main is undeclared main package. So what? Which is our entry point? Our entry point is go. Okay, I think just need to do go run main. Yeah. So I think we need to just have a working version, then we can test it with the API itself. So need to have a channel which will hold these tasks or hold the tasks in the queue. Whenever you add a task, it just comes into the queue, right? So let's take tasks is not list of tasks, but it's going to be list of, how do I do chan? List of channels. So I can do this, make this thing, but here I think let's say chan, do this task. Yeah, I think I can do that. So here when I get tasks, or let's say the task queue, right, should be make, yeah. So we're going to do this, and whenever we are going to add, we're going to take a task as well, the actual task name which we're getting, and then we're just going to put it on to the queue. Let's say queue dot task queue. We're going to put that with a new task, and that is going to be an ID is going to be the task. I think this should do channel of tasks. Queue size. If it's empty, then what's the meaning? I think it's one, right? The queue size will be one. I think let's see. I think that's fine for now. But just because of adding this, I don't think it would work. So adding to this queue, there must be some process which is going on so that it monitors for this task queue, and then it picks up tasks and then calls the dispatcher, right? So let's create that. I don't know if we can tie that to the queue, but uh, let's call init here. Maybe how do I block? I know I can block like this, but can I do select on this? I don't know if I can do this. Um, task. Is it select or I think it should be inside a for, right? The select would be again like a switch, but this is a case. But I don't think this should be a case. I just want to get that. Get the task, uh, and then call the dispatcher on this. Dot dispatch e dot id. If error is not nil, then I'll just say I shouldn't use prints, but I'll just use this for now. Um, else, so we don't want to return this from this function. We'll just do task done, and they'll just name the task is id. And when we are calling the queue, we need to init the queue, I think. Um, so let's say this is queue. I'll return queue. Before that, I'll say queue dot init. So this initializes this task queue, and because we are calling this in a Go with the Go keyword, so it creates a Go routine and then waits on this channel. And for this is an infinite loop, and for each thing we are going to be waiting, right? So this is okay. So let's see. So how do I get c dot body or JSON? Let's say schedule request. Maybe I'll just add task ID. Um, yes, and S is going to be schedule request. S schedule request, and then I can have task ID. So let's say Q is Q accessible. I don't know if don't even need this. So let's see, we can move that if you want. Can I say now Q? No, new Q. And Q dot add a task, which is going to be S dot task ID. We get an error. I'll just log that for now. Or I'll just send string. Can I send the status of 500 and send string the error itself? So if you see here, we are just putting this into a task queue. So I don't know if this will block. This shouldn't block usually. Let's should we call this? No. But I'm not sure if we need to build, I think. We have queue. Yeah. So we need to let's open this because we need a post request. Yes. So let's do 3000 slash schedule, and in the post request I'm going to send task. What did we name that? I think we need to add that here as well. What is the task ID? We'll have the task ID. Let's say if I give a random thing, let's just see if it works. We need a post. It says job schedule, but why? Just print error here. We need more logs, I guess. Error is nil. That shouldn't be the case. Okay, I think we are returning nil, but we don't know what's actually happening, right? We need to actually see if it's in the task, but what I want to actually see is if we give a correct one, like sleep time, it's a sleep 5. Does this print anything? The job is scheduled. I don't see anything printing here. We have a log level here. We are adding to the queue here, and let's say, okay, we're not receiving any prints. Not seeing any prints, logs, and go further. Any Something should, if I give a task to this, wait, let's say it's waiting here. Okay, I think queue is created when we are doing this. It's waiting, and when it gets something, let's say got task p.id, right? Yeah, we're not getting the ID here. What if I don't do this? You still get the task? Okay, I don't get the task. Ah, okay, I think the problem is here with the, what do you say, s dot task ID, right? If I do this, it's not, it's empty, right? If I do this, I mean, there's a better way to debug, but I'm just going on the go. See, there must be some, how do we do that? This, actually not sure. So let's go fiber post body. Okay, I think it's the reverse. So this should be this. This should be this. And now if I do, let's say 1, 2, 3, 4, some job which is not there here. Yeah, I think now I'm getting. If I say sleep 5, let's say if we are printing something. So it says we got the task this and it's dispatching this. That's fine. But we're also calling the worker, doing the work. Let's print here as well. Doing work for d dot task dot id. Yeah, work done for this. Not printing, but wait, how is the work done that way? Is there an error? Task not found. Okay. Why is it not found? Wait, why is there? Clip 5 is there here then. Task list. W.task list. Let's print the task list as well as the task. Okay. It's empty. Oh, I think are we calling a new, are we calling the new worker here? Yeah, that's the problem. Let's try now. Yeah, see, the job is scheduled here. This actually it works because dispatcher 33. Okay. because the error is nil. We are calling error.error, so that fails it. So if I see this, right, if I do sleep 10 here, so if you see the response, it's very immediate that the job is scheduled. In the background, the job is running. Um, Maybe we need to display some information here, but and you can see it was waiting. It got a task, started doing the task, and then after doing the tasks, it goes again to the waiting state, right? So let's say if I have 1, 2, 3, and what happens? You see that it's happening concurrently, right? That's what channels is for, and we can actually restrict this. I think let's try with where do we go? The queue, I think. Let's make it one. So we make it buffered as well as one at a time, I guess. Let's see if it works. 1, 2, 3. You can see 1, 2, 3, 1, 2, 3, right? One at a time. Great. But I'm still thinking. Got task. How many times have we got task? Before finishing this, we got the we started processing another task. So is that okay? That's what we need to decide on. As it comes, I think it's picking up. But what I'm looking for is finish one and then take the another. What is that? Okay. Because there's this task queue. Um, Where's my recording? We have this task queue which we are putting it in, but the dispatcher should block usually. But how are we getting that uh, go channels one by one? Mhm. So let's see. Sense blocks. Okay. Yeah, so I think as I said, we can have this two here and it blocks it's usually like two at a time, I guess, because it blocks until at least one of them is free. If I go like 1, 2, 3, 4, 5, right? Yeah, I think it's doing one by one, that sequential. So right now we are doing in the for loop. Um, but I think the problem is with the dispatch because here we are calling the worker. The worker should block usually, right? It should block, but it's not blocking. Okay, the task done is also after this. I think it is blocking, but when we are adding to tasks, this is getting triggered, and we are putting that into the tasks. So we have to see if that's what we want. Um, just say, I think this is fine. Um, let's see if we can consume. We can do weight groups, but I think channels are better, not weight groups. I don't know if okay. Um, let's maintain the order first. I think you might be going to weight groups. Yeah. If there is something related to ordering, then people go into weight groups. So I think this is good enough because anyhow the tasks are being dispatched one by one. But we need to make sure that the job is done. Then the task is picked up. So I'm just seeing what can be done. Like what I'm looking for is you one, but then still it's not waiting. It is okay, but I actually need the queue kind of thing where um where we just put in queues, I mean put in tasks and it just picks one task, finishes it and then comes back. It's another one. Maybe we need to range over the channel. That again still I don't know if it will block. Um wait for let's see here. We need to close the channel as well actually. So we can do this, but this will just be done for it and it will close it. Mm, just putting a task into that. What can we do is that maybe we can use weight groups or we have to find some property in this channels. Or channels examples. A channel buffering. I think the problem is we always have a receiver here because we are waiting on this. But we need to make sure the previous task uh, is done. So if I say time dot sleep 10 into time dot second, for example, does this block the task? If I do 2, no, right? Because This is just putting into the queue. It's picking from the queue channel, and it's receiving from the channel. We're just dispatching it. Or should we haven't added the retries? We have to increment the retries. So there are two concurrent processes running, but this doesn't work if the queue itself is dependent. I think this is fine, but um, if we have 100, then what's the case? Let's look for n. It's 8. Yeah. Tries to clear the queue as fast as possible. But can we do a wait on this? Let's say where did we do that? Queue, right? Yeah. So here when we can create a wait group here when we're initting it. And then I can say, let's say add one, and then here I can say add one, and then done here. Wait here. I don't know if this works, but um, so what do we actually need is not wait groups, maybe, or maybe wait groups, I'm not sure, but channels with for. Buffering, we have synchronization. I think, yeah, this is what we're doing. We are blocking like this. At the same time, we are getting the result as well. Yeah, they're not consuming the result, but is there any ways to make channel wait? So what they are saying is we put this in a queue, right? Instead of having channels, we add it to the task queue, but we get that here. But I think we need to check. But as soon as it's put in the task queue, right? This happens. Like this consumes immediately. Like this loop goes on, and then it starts to dispatch that immediately. Whatever task comes in. What I'm thinking is maybe we can have a wait group. Um, so if I don't have this for loop, right, it just happens once. If you see, I think that's right. If I give two, how is that possible? I'm initializing it, I'm waiting on this, but I don't have for loop here. So it's waiting. Okay, we are creating a new queue every single time. Got the point here. So in main, I guess, we shouldn't create a new queue every time. So let's say new queue, but how do I Can I add a middleware here? I just want to attach the queue here. Middleware and go fiber. Hmm. I just want a custom middleware. I think we can just do use and print this. So before doing this, I want to say c dot context or request locals. Okay. I think the queue would be where's the queue? Very great, yeah. This. And here the queue would be c dot locals get locals. How do we get it? The key is queue. Queue is equal. Can we do this? Ah, I think this is fine. Okay, we'll do this. So this should be fine. Let's see what's happening now. Yeah, now it's waiting. We only have one queue. We added another one. Another one. Yeah, so now it's coming one by one, right? That's what we need. So if I go again, if I do 1, 2, right? Now it's going for the first task. The second task is still pending in the queue. The first is done, then the second comes in. This is great. This is what we wanted. So yeah, so the way we are using the queue is like this. We had create a new queue and we add the tasks to it. Um, but I guess this is working. Um, queue waiting, queue in it. Done, I guess. Or started. So we don't need this tasks array. So dispatcher as well. I think there's like too many logs. Let's remove this. So as per the error handling, so let's say if this uh, fails, right? Some error in sleep 5. So now let's see if how are we handling the error. For the retry, let's add this log as well. Retrying task count is retries. Come on. Mm, okay, let's run this. We are just trying to restart, retry this. It should fail. Retry count. It will wait for 1 minute, but no, we just wait for 1 second. Number of seconds. I think we need a value here, right? So there's one count. Do that again. Count 2 seconds. Count 3 seconds. Yeah, yeah. I think this works as we expected, right? But why did we get the queue in it started again? Okay, I think it failed, right? And then it came in again. I think that's fine. Just put this outside. As you can see, we are retrying this with not exponential, but for now it's just uh, incremental seconds. But again, after retrying for certain time, it stopped, which is what we want. And and here we gave the channel size to be 1. So um, it until there is some one receiver at the end, it will block the channel. So which is what we exactly want, because we want a queue. We want to be functioning it as a queue, right? So we just need to be taking one by one, and until they're finished, we'll just block it. And I'm just seeing if we need to do anything else, because we just got everything working, and it worked better than expected. Actually, this retry mechanism is also working. So right now the problem here is it's everything is in memory. Nothing is persistent. Maybe I'll make another video on the same, but yeah, maybe the possible way is to store the tasks in the SQLite, and when you restart this, right? You just, uh, you know, you just add, you just pick up from the SQLite DB as well. So for every status update, you just have to keep updating um, the DB. Can we do that? So the flow is will be something like, I guess, um, so first init DB file. Then what we can do is task. When we add the task added update DB. Again task updated update the DB. Init DB get or not okay. I think in not okay, or I think waiting, right? In progress. Task from DB and load it into memory. So by load it into memory, I think we just need to add that as a new task to the queue. So let's see if we can do that. sqlite go. Yeah. So let's try to install this. But how do I? Let's just install this. How do you use this? Yeah, we need the examples. Um. Okay. Let's take this. How are they initializing this? Wait, what is? Do we have an SQLite viewer here? No. So so let's do this. When in the main, right? Let's create a db.go, which is a package main. Everything is package main in this, so there's no worry about packaging. So we have a db struct, which I don't know what the type of this is. Let's say connection is going to be SQL. This let's try to initialize it here. Q. I think first let's we have to see what is this doing. SQL.db. Okay. So db is what we need for let's do new db. This is going to send a db connection. Okay. Structure the pointer db. And we're going to be returning db with this. But before that, I think we need to initialize this. How do we do that? I think that's what we did here. And it's going to be db. I think that's fine. So here, I think we'll just create a db and error, but from new db. If error is not equals to nil, then we're just going to stop the program. Error initializing db. We need to do something with the db now. But before even creating this, I just want to do a query. So I want to do create table if not exists. I don't know if I can do this, but so can you do a create table here? I want to do the SQL statement here. So create table. I need if not exists because I just don't want it to throw error. I don't know if it works here, but let's just try. I just have to check. So we need a table. Let's say tasks. It just has a task ID and the task ID name status. I think ID is going to be varchar or 64 not enough primary key. Name is again going to be varchar of 64. Status is as well going to be varchar of 64. Let's just create this as well. Let's see. Yeah. Great. SQLite. Okay, do we need to? Okay, we need an named import here. Why is this hanging? I'm not able to save this for some reason. Something is blocking. Okay, did it create? Or I think we need. Did it create a folder DB now? I don't know if it's. We didn't get that print, right? We just need to see what's breaking. Okay, is it? It's a. I thought it was query. Why is it blocking? Something blocking here. Oh, something is blocking. Let's open Studio Code and see what's up. So usually we are just trying to create. I mean, right now we are trying to create this table, but it doesn't seem to work here. Okay, is it? Okay. So if we go to db.go, if we try to save, it's saving. This doesn't seem to work for some reason. Is it the only one we have? Okay. Just go here. This is very old, I guess. Hmm. Just trying to get some sqlite driver so that it should be sqlite 3 is there, right? Yeah, it is. What's the problem? I don't know. Is it not? Oh, okay. I think it started now, and we do have a Go queue, so it has created a table, I guess. Let's see, SQLite reader on it. Let's just take our Go program. I mean, Go folder. This is a DB file. Yeah, I think there's a name. Oh yeah, there's a table. There's ID. There's a name. There's status, right? So whenever we get now, the job is to actually we need to attach this to a middleware so that we can use this everywhere. So I can just do this. So now when I get this call here, I'll just add it to the queue. Let me to add the context. Need to add the context, I guess. The queue. I guess we can give the Fiverr context to the queue. Just SETX. So I could say like this, and here, yeah, we need a context here. See, I think it's not a pointer. So I'm not sure if this gives us but I guess if we have the context here, we can move it anywhere. And if we got a task, right? First, let's q dot etx dot locals of db, and let's do this to sql dot db. Maybe comma error. I think I'll just ignore the error for now. I just need to insert. We need a task ID also. But for now, I'll just create IDs like this. I think it should be the name actually. This is the name. The ID is, let's go with something like this. Task ID is this, and we'll use the task ID here. And what else are there else? So if I do db dot exec something, the query, so I'll just insert the query here. We're going to be insert into tasks of ID, name, status, and the values are going to be, wait, how do we insert this? Okay, question mark. Wait, where are we? Okay, we can exit like that. Okay, so we can actually give this, and when exiting, I think we can just give the ID, which is a task ID, the name, which is the task, status is waiting. As this works, and when we are updating, right? So here we got the task, we are dispatching this. But with the new dispatcher, again, we need to give the context, right? So here again, it takes a context. We're going to be giving that here. And when you are dispatching this, we're gonna call the, yeah, this can be the ID, but we'll also send the ID as well. Task ID and task name. I think that should be more. So the ID is actually the name. We should change that. So do work for this name, not the ID, right? And now we need to update this, that this is happening. So here we need to update the d dot locals of db dot ul.db. So again, db, we're going to do this. Let's set the query, but the query here is going to be, how do you update entry sqlite? Update tasks set status is equal to processing where id equals to this. So where did we go with that? Yeah, where id is this. We'll just do this d dot task dot id. And again, I think we can just create update task status, task id and the status both are strings. And this will, let's just move this here. And I'll just do task id. And this is going to be, I guess, an a printf statement. This is going to be a status. Error handling, I'll just take care in a minute. But before that, I can just now call update task status with d.task.id and then the status. And after doing the work, I can do this here. Not okay or okay. So again, this works now. So when we are starting up, right? When we get the DB here, we can ask the queue to load up the tasks. So let's actually just test this now. Q.225. Oh yeah, we need the context. Yeah, t.id and t.name. So now when I do this, what is the problem? I'll just do this again. This is returning some error. Q.go55. Okay, wait, is DB null or something? We need to check the type of DB. Oh, it's DB itself. Yeah, I have to do DB dot on dot this. Where else have I done this? In dispatcher, right? Yeah. I just need to do this. Now still get this error. I think this is in Q54. I will not initialize this connection yet. That's how they did. Like, they call this open. Okay, do we need to do? Why is it returning this? If when you're executing, then it should still work. Let's see what exactly it says. Okay, it's nil. Wait, how can it be nil? Because the DB here, I'm getting a new DB, but yeah, I think this is fine. Okay, is it star DB? Because we should just map it to the exact type which we sent. This is smaller, but dispatcher 33. It's the same, right? We're doing star DB. EX locals. Oh, it's the same thing. Am I sending this correctly in the CTX? I'm setting this here. Yeah, I think this should be fine. Not sure why I'm getting this. 43. Yeah. Um. Oh wait. Should we send the pointer then? Because the values, I don't know if they carry up. We should see what do they have here. I think it's just seeing. It's very hard to get this working. I should have picked some. Wait, this is returning nil. So there is no locals in this CTX. This is, are they saying that? Hmm. But that worked for the queue. Don't know why it's not working for this. How do you even? How do I? Maybe for now we can just supply that to the, instead of the context. It's very messy. We can just send the DB itself like this. I don't need this here. Can I do that? Because if I do that, um, problems will become much easier. I don't need the CTX. I can just do this. I can just have the DB. It's DB. So again, if I go to the queue, maybe what am I missing now? I don't need the context, so here I can just say I don't need the context here. Then it's the same dbdb, and I can just do db is d. So we can just do q.db. Don't know if this, yeah, we don't need this db. We can just move this out. I can just run db here. Yeah, it works. Actually, let's in the worker, let's just remove the error here. So wait, I have to see if it wrote to this go queue. Do we have anything? Yeah, we do have this. Awesome, right? So we have these tasks. So everything in the tasks, actually, let's remove this. Let's do this one. Let's do one thing, one query. We have one task now. It's okay, right? So now what I need to do is I need to just get the list of the function load items, load tasks from db, right? So I need, what do I need? I need the db, which is the db, and the queue, which is the queue. I need both of them as pointers, probably because I am going to update this, modify them, but I think that's fine for now. So whenever we load up the queue, after loading up the queue, I'll just say load task from db, the db and the queue. I'll just send it like this. So now I have to run a query here, db.con.x statement. Statement is going to be, you'll have to standardize this. It's either query or statement. Let's do query. So select star from, I just need the name from tasks where status is not, where not in sqlite. What do I need exactly? I just need status is not, yeah, it's not in just need in, right? If it's not okay, if it's not okay, we'll just leave. If it's in waiting, or wait, just need the list of, so it's waiting, processing, okay and not okay. So for from the db, we're going to pick up waiting, processing. We're not going to pick up okay or not okay because they're finished. I'll just add this. So the question is, how do I convert this into a struct? Like, these are the rows. Okay, I need to do that. I'll just pick up this. So I need to refer rows, and I'll do this. Exec, right? Okay, it's query. Okay, query means we're going to do the select, and exec is something modified operation. So I just need the name. I'll just do this. So if error is not equals to nil, I'll just return the error. Just return nil here. So we'll get the name. And with the name, what I want to do is I just want to do this, right? Further I'll just print restoring task item. What was that? Name from DB. So what I will do is I just need to verify this. Does this work? Okay, so what we need to do is I'll just go here. I'll just fire some this thing. But why did it stuck? We'll just see what's happening there. But okay, there were some processing waiting, right? So now if I try to load this, yeah. So should there be a task ID as well? Should we store the task ID? Let's get the ID as well. So if you see, I think we have one more. No, I think it's done. If I try to 2, 3. Okay, third one is getting blocked. But the queue shouldn't get blocked. Why is it getting blocked? Okay, this is getting blocked. So if I remove this, let's see. We need a bigger. I said 1000. It's the size of the queue. Yeah, that works. Now if I go back, is to reload this. There are so many waitings, right? So I need to is the main. So we are selecting this, scanning, I think. Let's just run the server. Why is it not? If I open this, there are so many with this thing, right? Okay, I think it failed. We have to handle that as well. So if again error is not equals to null, I'll just stop this. Error loading task from the. I'm not sure if we need to stop the server for this, but I think that's a correct way to do. So we get this, it's restoring this, restoring. It's one by one, it starts to restore. But my question is it restoring? Okay, so this should be. Should this be a concurrent process? That's the thing. I don't think it's a concurrent, but is it waiting for 5 seconds really? One, two, three, 4, 5. Looks like it is. I think, but it's stored inside the. Wait, is it restoring task item should come? Yeah, so it is restored, right? But after that, we are it's just consuming after that. So I think this is fine. So yeah, I think that's it for the video. We achieved what we wanted. So there's a single node job queue, and as you see, we even added persistence where we try to uh, persist the tasks. Um, I think that is great, but I think there are. This is not that stable as per my view, but for the initial prototyping, I think this is great because this actually works. You can use it for low loaded tasks, right? So yeah, that's it for this video. See you in the next one.